Okay, so declination. This is the, I forget the definition, like angular deviation between true north and magnetic north. So when we find our degree of travel on the map, we mark it down, we know that's grid north. Make sure to mark that grid north. When we convert it to our compass, we can't just go, okay, 355 degrees, set it on our compass, and then go that degree of travel. Because it will not match up. Grid north and magnetic north aren't the same. That's where you get into declination on a map. All maps should have a declination diagram that usually tell you pretty much what to do, but it's better to know at least a little bit of why and how you're doing that. So getting into declination, this is a really good, useful tool to use, but just a brief kind of like understanding of it. I'm probably going to butcher this, but here's a beautiful drawing of the United States. Look at that. Awesome. Texas, Florida, Maine, Cal. Okay. So there's something called the isogonic chart, and that basically shows a magnetic line running through, which is somewhere around here. And then it shows the declination lines that kind of show how your compass points. I'm not going to go into that. The line in the middle, I didn't do this very good. The line in the middle is the agonic line. So basically, if you're in that area, and this does shift, if you're in that area, you do not have to, the grid north and magnetic north will actually line up, and you don't have to do anything. When you get your number down for grid north, when you find your degree of travel, that's what it is. Set your compass and you're good to go. But if you're not there, if you're more easterly or westerly, you are going to have to preset your compass, add in a number, take away a number to set your compass to. Now, there's two main types of compass, a lensatic and a base plate. I think lensatic are more durable. I like them better, but base plate, you can actually change the declination on the compass and you don't have to worry about it. It's kind of simpler, I guess, but I like going through it methodically and mathematically to know why I did everything I did, rather than just one setting. But that's just preference. So basically, the confusing part of this where people get messed up is this is eastern United States, obviously. This is western United States. But the way the lines angle because of the magnetic pole towards the agonic line, the lines on the east side are actually considered to be westerly leaning lines. And the lines on the west are considered to be easterly leaning lines because they're going towards the east, and the lines on the east coast are actually going towards the west. It doesn't really matter that much right now. The big thing is, this is probably a good chart to remember. And they use the acronym LARS, left add, right subtract. Now that still can be confusing. Now again, a lot of times your map's going to tell you what to do, but I would say there's a lot of tips and tricks, a way to make it really simple, which way to turn your compass. But I feel like to understand it, how I would explain it would be, on my map, I know that when I get my reading of my degree of travel, like we did, and I wrote it down on the other side, I found grid north. I was using grid north. Now I want to change it to magnetic north, so I know that when I go out, I can set my compass and know it's the right thing and I don't have to change it anymore. So I want to change those two numbers. So let's take this. It was 355 and 85. I'm going to put them over here. 355 and 85. That was starting point to alpha and alpha to Bravo. Those are both grid north. I want to change it to magnetic north so it matches exactly on my compass. So in my area, and there's actually a site for this, I think it's called NOAA. It tells you, because declination does change, so things shift. It tells you the accurate declination of your area. I think mine is actually 13 now, but we're going to go 14 because that's what it says here for simplicity. So I'm going to ignore this negative because that doesn't really matter. 14 degrees, so I got grid north. I need to change it 14 degrees, either adding or subtracting, to make it magnetic north. So I know what to set on my compass, because again, if I set this on my compass, it will be wrong because I'm not on the agonic line. So what I'm going to do is to know if I need to add or subtract. I know it's 14, but I don't know if I need to add or subtract it. So I know that my grid north, I marked my grid north, and I want to make it magnetic. So I'm going to add it because on this one it shows the magnetic to the left of the grid north. So I know that I'm going to use this side of the column because it shows it on my map that I'm going to go towards magnetic north because I want ending in magnetic north. So I'm going to convert it this way, which means I'm going to add left add, right subtract. So the confusing thing is it's the opposite if you're going the other way. If you find a point in the map with your compass and if you find a point when you're outside on your compass, a degree of travel, and you want to plot it on the map, now you need to go magnetic north to grid north because again, it's different. So the same thing applies left add, right subtract. So if I find a bearing on my compass and I'm moving it towards grid north, I'm going to need to subtract it depending on where I'm at. So it all depends on where you're at in the earth. So I usually make it easier by going, how did I do that? I usually mark down here, west, so I don't get confused. West coast, east coast, which is kind of confusing because this is right and this is left, but this is what makes it easy to understand. I know that I am, and again, if I'm always doing it in the area that I live in, it's pretty simple. I'm always going to add. When I'm going grid to magnetic, I'm always going to subtract when I'm going magnetic to grid. And again, this map doesn't tell you much. A lot of maps are going to tell you in detail what you need to do to get that declination right. But I'm trying to give you some science behind it. So I know that I'm on the east coast. So if I'm ever going grid north to magnetic north, because I'm east of the agonic line, I'm going to add to go grid to magnetic. If I'm going to go magnetic with my compass and get it plotting on the grid, on the map, I need to subtract to get to grid because I know that I'm on the east coast. Again, I can also look on here and know that it's to the left of the north, so I know that whichever way I'm going, I can use that too. There's a lot of simple ways to do it too, to know what, there's a whole bunch of tricks I've seen where you always turn your compass this way if it's pointed this way. But I think I got confused in those because it might have helped me at one point and then something came up and I didn't know why I was doing it. So that's why I show agonic line on the isogonic chart. All these lines of declination, there's a certain number. I don't remember exactly how many it is. But again, westerly lines have, on the east side, they have a westerly declination because they're leaning in towards the agonic line. And then on the west coast, they have an easterly declination. And that's why when things are written out in text, it gets kind of confusing. So this is the chart I go with. Left add, right subtract. I put these down to help me quicken it a little bit. And then I do this. So basically I know in my area, I am always going to be adding 14 degrees for my declination. So my declination is plus 14. So what that means is I am going to add 14 degrees to these numbers to change them to magnetic north. So now I have the exact degree of travel. I can set on my compass. I know how to set out to go to each point. So what is this, 99 degrees? And now that's magnetic north. And then, gosh, 60, so 9 degrees magnetic north, right? 60 makes it even, 9, that's right. So now I know that I can set my compass. Do you see an ambulance, bud? Now I know I can set my compass. So I can turn my bezel ring, and I'm going to take this tritium marker, and actually I'm going to orient my body. So let's see, my first from starting point to alpha is 355, that's grid north. Magnetic north is 9 degrees. So I'm going to change this until I'm at about, this is probably hard to see on the thing, about 9 degrees. And I'm going to line my tritium marker up with my north-seeking arrow. And now I know these two should be lined up. If I ever walk and I'm out of line, that's why you want to check pretty often. I want to make sure I'm orienting my body, not just the compass, to get back in line so I know I'm going to that degree of travel that I need to get to my next point. So then once you get to, so 9 degrees is going to be my compass setting to get to point A. And then I'm going to be doing 99 degrees to go to point B.